Hi everyone, this is Mr. Jacobs, and we're going to talk about modeling math problems and how important they are to visualizing the math concepts that we see. So let's say you need to show visually the number 12. How can you do that? Modeling is important to visually see what is happening mathematically. It is another way for our brain to learn and see the mathematical concepts instead of just memorizing an algorithm or a mathematical step. So one modeling way that we've learned is to break 12 into maybe 3 equal parts and then distribute the 12 across them and see how much we get in each group. So we get 4, so 3 groups of 4 each. Another way might be to make like an area model. So 3 on one side times 4 on the top. So 3 groups times 4 groups. Another way is we might use a number line to show 12. So we start at a segment point and we go by threes. So 1 3, 2 3s, 3 3s, 4 3s. So there's lots of different ways to show 12 visually. Okay, without writing anything down, I just want you to solve this multiplication problem in your head. Okay, the problem that I want you to solve is 18 times 5. So solve that in your head, use whatever method you have, and then be able to tell us about it on how you solve this in your head. Go. Okay, I want you to solve 12 times 9. So now I want you to solve 12 times 9 in your head first, and then I want you to show us a model. And I want you to show the model right here. So draw your model after you've solved 12 times 9 in your head. Okay, so we've talked about modeling, and here's some examples of modeling of whole numbers in different ways, in multiplication and division and adding and things like that. But can we model fractions? Can we model division of fractions and multiplication of fractions? Why don't we take a look? See if I can get rid of this. And I want to add this. Can we do that? 5/6 divided by 1/3, 5/6 times 1/3. How would we model that? Well, I think the beginning of what you would do is fractions are part of a whole, right? So let's start with wholes. So here's one whole that's sort of thin for the division and a more of a box shape for multiplication. And what we would do, okay, is we want to break these into 5/6. So here I have 5. Actually, let's change that to this color. 5/6. And here we would have 5/6. And if I were talking about 5/6, I think actually even if we have 6, we need 5 lines. So I'm going to put one in the middle and one in the middle. And then we need 2 over here and 2 over here. I want to do the same thing over here. Why don't you count? Make sure I have 5/6. See if I did this right. 1, 2, 3, 4, 5, 6. Okay, so now I have my 5/6 shown. 5/6 of a whole, right? So let's show the 5/6. So 5/6 of this whole would go all the way over here. So I would have 1, 2, 3, 4, 5. And I could, let's see, well, I could shade this in, I guess, like this. So that would be 5/6 of the whole. Do you see that? I would do the same thing over here, but this one I don't, well, I could do this, I guess. 5/6 of a whole. And then I want to shade this in going this way. That's sort of harder to see. Yeah, I can do this. So now I have my 5/6. I guess you can see that. I have 5/6 of my whole going that direction. Do you see that? But I still have to put my third in, 1/3. I'm going to put 1/3 over here. So I want 1/3 of the whole is right there, is it not? So I can label that 1/3. I have another 1/3. And then I have this other section. How much is that? That's actually half of 1/3. Okay? So I have 1/3, 2 1/3, and a half of 1/3. So our answer to 5/6 divided by 1/3 is actually 2/3 and 1/2. Does that make sense? So we can do all of this division without actually doing the calculation part if we do the model correctly. So what do we do for multiplication? Multiplication, we have to do sort of the same thing, but we're multiplying. So I have a model of my 5/6 here. How do I add my 1/3? How do I show my 1/3 on here? So 1/3, how about we put it on the side over here? And so we're looking horizontally on our model, and we want to break it into thirds. So thirds is maybe about here is 1. If I can break this, so I have 2 lines to break into thirds. So so now I have 1/3, 2/3, 3/3, right? And I'm trying to see how many thirds there are when I multiply. So I multiply 5/6 times 1/3. That's sort of like an area model, and that's what we've set up as an area model. Width times length. Okay. Now we got the width, so we're showing 5/6. We want to do times 1/3. So what we need to do, oops, wrong thing. What we need to do is we're doing 1/3. So I can look in here. This is my 1/3. Do you see that? All over here. And do you see how my 1/3, what's overlapping? What's overlapping that's brown and blue? So do you see here I just have blue, but here I have brown and blue. So this is 1, 2, 3, 4, 5, and it's a little bit hard to see, but I have 5 that have both, so that's going to be my numerator. And then I have to count how many total I have. So I have 6. Where's my little dot? There it is. I have 6 up here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have 18 whole parts now. Okay, so my bottom is going to be 18. Okay, then I look at this and I say, can I simplify this? Is there a common factor between 18 and 5? I know 5 is a prime number, so that it has a common factor of 1 between them. So there is no common factors besides 1. So my answer is going to be 5/18 when I multiply 5/6 times 1/3.